Our next application of the derivative in business is really important. It is around this concept of inventory cost. And the idea of inventory cost is you want to make sure you have enough stuff to sell your customer, but it costs money to store that stuff, but it also costs money to order that stuff. In other words, there's two costs that you have to consider. The holding cost, the cost to store the stuff before you sell it, and then you also have to reorder stuff when your stock gets low. So the function of this is going to be the C of x, which represents the inventory cost, is equal to the h of x, the holding cost, plus r of x, the reorder cost. Now, if each order is the same size, if each order is x items, on average, we are holding, you got to think that x items is going to go down to 0, and then it's going to go back up to x. Then it's going to go down to 0, then it's going to go back up to x. If we average x and 0, x plus 0 divided by 2 is just x over 2. The average amount we're holding at any time in storage is x over 2, which means our holding cost, h of x, is going to be the cost to store units whatever that cost is, times that average x over 2. And if orders are evenly split, the number of orders is the total number of things that we're ordering divided by the number of items. That'll tell us the number of orders, which means the reorder cost is going to be the cost to order. Maybe that's a delivery fee or a processing fee, times the number of orders, which is the total number of things divided by x. So if we put this together, let's say a company expects to sell 980 widgets. If the cost to store a widget is $34 per year, and the shipping cost to order more is $85 per order. How many orders would minimize cost? Well, let's break this down into our holding cost and reorder cost, and then try to minimize the total inventory cost. H of x, the holding cost, is going to be the cost to hold it. The cost to store it is $34 per year times x over 2, because that's the average number of things you have in storage. Well, 32 over 2 reduces to 17. So the holding cost turns out here to be 17x. Let's look at the reorder cost. The reorder cost is the cost to order. The cost to order is $85 per order times the number of things we expect to sell, which is 980, divided by the number in order, which is x. 85 times 980, that's going to be 83,300 divided by x. And so when we put this both together, we get our total inventory cost is going to be the holding cost of 17x plus the reorder cost of 83,300 over x. But to make the derivative easier over x, I'm going to rewrite as x to the negative 1, because we know that the minimized cost, the minimum is going to occur when the derivative is 0. So we take the derivative of the cost is equal to 17 minus 83,300 x to the negative 2. But that x to the negative 2 is the same as over x squared. That's going to make it easier to solve when we set that derivative equal to 0. Adding the fraction to both sides, 17 is equal to 83,300 over x squared. Multiply both sides by x squared, and 17x squared is 83,300. Divide both sides by 17, and as I'm running out of space, we'll come up here and get that x squared is equal to 4,900. Take the square root of both sides, and x is equal to 70. Remember, x is the number of items, so x is 70 items that are going to be ordered each time. The question, though, is asking about how many orders. So if we want to figure out how many orders, we just take the 980 widgets that we're starting with and dividing by the 70 items. And that's going to give us 14 orders. So we have 14 orders of 70 items. I guess they're actually widgets. 14 orders of 70 widgets. Widgets should have a D in it. We'll minimize our cost. And we actually could go one step further if we wanted to actually figure out what the cost is. I could use this cost function. I can plug in that cost of x, x is the 70 items, is equal to 17 times 70 plus 83,300 times x, which is 70 to the negative 1, which really means divide by 70. And when I put that on my calculator, I get that cost, the total inventory cost, is going to be $2,380. So our inventory costs are those holding costs plus the reorder cost. Taking the derivative and setting that equal to 0 will minimize those inventory costs. Our next video is going to take a look at a third example of an application in business and economics of that derivative.